Hello, everyone. Thank you for attending this webinar today. We were very excited to be here with our friends from MLOps to talk about building an LLM fine-tuning workflow using ClearML and DolphinScheduler. I'm Tina Meyer, Senior Director of Product Marketing and Growth from ClearML. ClearML is a unified open source platform for continuous machine learning, trusted by forward-thinking data scientists, ML engineers, DevOps, and decision makers at leading Fortune 500 companies, enterprises, academia, and innovative startups worldwide. Before we get started, there's just one housekeeping item. If you have any questions during this session, please submit them at the chat window at the bottom right lower corner of your screen, and we will address them at the end of the session. For presenting today are Jill Guangzhou and Victor Stock. Jia Guangzhou is a senior machine learning engineer at MLOps with several years' experience in the NLP field. He has led machine learning teams and is an Apache DolphinScheduler committer. He excels in various NLP solutions. Victor is an enthusiastic machine learning engineer and tinker. Having worked on dozens of machine learning projects in the world of consultancy, he's now focused on making really cool happens in the space of green energy. Victor enjoys public speaking and is happy to share the magic of machine learning with anyone willing to listen. Today's agenda includes an introduction to DolphinScheduler, introduction to ClearML, and then we'll move into a demo for building the LLM fine-tuning workflow using ClearML and DolphinScheduler, finishing off with a Q&A. And now I will hand it over to Jaguar.
Hi everyone, I'm super excited to share with you how to build a large language model fine-tuning workflow using ClearML and DolphinScheduler. Just a quick intro about me. My name is Jie Guang and I'm a machine learning engineer. Here's my GitHub and email. If you have any questions about what I've shared, feel free to reach out and chat with me. Recently, ChatGPT has become very popular. In the open source field, the large language model community is also very active. Last week, Meta released Llama 2, a very powerful base model. Today, we are going to build a fine-tuning model workflow for a large language model which used Llama 2 as the base model. In this part, I will give a brief introduction to Apache DolphinScheduler. This is a platform for building reusable machine learning workflows. Apache DolphinScheduler is a powerful distributed open source workflow orchestration platform. It is good at building workflow reusably. It can execute millions of tasks with high stability. In addition to common workflow scheduling functions, Apache DolphinScheduler also supports powerful workflow version control and data backfilling. It handles complex task relationships such as dependencies across different projects and workflows. DolphinScheduler offers a lot of ready-to-use task plugins. These include big data task plugins like Spark, Flink, the machine learning task plugin such as DBC, SageMaker, PyTorch, and Jupyter, and some scheduling logic stack, the soft workflow, dependence, and conditions. And of course, it supports basic tasks too, like Shell, Python, HTTP, and so on. This is an example of a machine learning workflow, which includes 4 tasks: the preparing data, training the model, deployment, and batch inference. Now, the training model task is actually a mini workflow in itself. Let's have a look at the picture. It's got a bunch of subtasks inside. It likes reprocessing data, training the model, evaluating the model, and so on. All we need to do is choose an environment for each task in DolphinScheduler, kind of like running shell scripts or Python script in the command line. Then we just link them all up. The workflow is super flexible with powerful features like retrying if something fails, log management, environment management, and scaling tasks. But if you have your own machine learning platform, or maybe you are using the third part ones, for example, the SageMaker, ClearML, you can totally use DolphinScheduler to organize them into your workflow as tasks. As you can see the image here, data preparation is done locally on DolphinScheduler, and then the model training part, that's taken care of by SageMaker. Before we get into the part about fine-tuning large language model, Victor's gonna talk about ClearML. Is very cool machine learning ops platform. So let's pass it over to now.
Alrighty. So thanks for the first introduction. DolphinScheduler is an awesome tool. And so now I'm going to introduce ClearML. So my name is Victor. I'm a developer advocate at ClearML. For ClearML, what it does, like what is it? ClearML is an open source end-to-end MLOps suite, right? So it's essentially, I always think of it as a toolbox full of tools that can help you in your life as a machine learning engineer. So right here, you can see we have different components, different tools. One of them is data ops. We have an experiment manager. There is training orchestration. We have reporting as well, model stores, pipelines, deployment, and that all is underbuilt by an orchestration layer that can either schedule or that can schedule your tasks on computation or on hardware. So today, the most interesting parts, specifically for fine-tuning the LLM flow, are going to be the data ops section, the experiment manager, and then the deployment part, right? So that's what I'm going to zoom in on right now. So first of all, ClearML has data version management, right? As you can see here, there is lineage. You can have different versions of your data set and keep track of them over time, just like Git would do for your code. So if I may show you, this is what that looks like in the ClearML UI. Let me make it a little bigger so you can actually see it. So you have different versions of different data sets right here. You can always see where they came from, what the previous versions were. And then obviously you also have things like previews. If you go here, you can actually see different previews, but they're not limited to what is actually in the data set. As you can see here, you have audio files in the data set, but you can also add anything that you want, right? You can add tabular data. You can even add plots, for example, a histogram of the different class distributions. So this is a very, very powerful tool to keep a very clean overview of the different data sets that you have. Naturally, each of them also have an ID, and that will become more important later on. But yeah, we'll go into depth in a little bit of time. Now we have the experiment management as well. So this is the second part or the second tool that we'll be talking about today. The experiment manager is essentially trying to keep track of everything that you do in every Python process that you do. And that's actually how it works together well with DolphinScheduler, is because DolphinScheduler does these specific parts or steps in your pipeline, and then ClearML can keep track of what actually happens, the inputs and outputs going in and out of each of those steps. So if we take a look at what that looks like in the UI here, you can actually see that I have a whole bunch of tasks here. And so every single line, every single bar here corresponds to one single time that I run my code, either completely standalone locally or as part of, for example, the DolphinScheduler pipeline. And then what you can see is we keep track of the repository, the Git repository that was used to run your experiment within. You also have uncommitted changes or installed packages. These are all captured automatically. You don't have to do anything else than add 3 lines of code to your training script, right? You also have configuration, which is, for example, the hyperparameters. You have artifacts, which are the inputs and output models. You have information on when it was run, on which machine it was run, which GPUs it had available, console log output, scalars, which are the very important ones. They're your metrics telling you how well your model is doing or how poorly your model is doing. There is plots as well. So if you want to add any confusion matrices or line plots, things like that, you can always do that within the experiment manager. And then finally, you also have debug samples. For example, you could show some bounding boxes on your object detection, or we also support text if you want to do LLM, like will be shown later on. Now, finally, the experiment manager is not limited to just keeping track of all your code. You can also use it as an organization tool. So you have a lot of different tasks here that you can assign tags to, and then filter based on those tags, depending on what you want to achieve. So for example, I want only the YOLO v5 ones in here, so I'll only get those. And it will actually filter based on that. So if I now go back, the final stage that we'll be touching upon today, and remember, this is all part of a larger system and it's completely open source. So we also have deployment, and deployment specifically, this is a little harder to show, of course, but deployment specifically will take your model that you trained in the experiment manager, or that was tracked by the experiment manager, and that was, for example, trained as part of a DolphinScheduler pipeline, and you can then turn it into an API, and then add some monitoring, add some statistics, and make sure that it's very visible what goes in and out of the model. Now, there is a lot of different options here. Obviously, serving is quite a big field, but for example, here you can see that we have 3 running tasks in the ClearML manager. One of them is handling the serving control plane, so you will have to do everything with this task. But then you have the serving instance and the statistics instance as well. And then this will tell you everything you need to know about, for example, which model is currently running. And then here you can see, for example, which endpoints I have currently running or which metrics are running on that endpoint. Model monitoring specifically is handled by your external tool. It's actually set up within Prometheus, and you can handle it with, for example, something like Grafana, which you will probably see later on. So this is a very quick overview of ClearML and what you can expect later on in the demo. So without further ado, let's take a look at how to fine-tune an LLM model.
Thanks to Victor for introduction. ClearML is very cool. Let me give you a quick overview of how our whole workflow goes down. First off, DolphinScheduler takes care of the preparing data. Next, DolphinScheduler passes the prep data to ClearML to keep track of different versions of our data. When it's time for model training, we can pull out a specific version of our data from ClearML. Then, DolphinScheduler kicks off the job of training our model, which actually runs on your own servers. During the model training process, ClearML is always on it, manage the experiment. This includes tracking details like model logs, metrics, GPU usage, and so on. At the end, after we are done training the model, we use DolphinScheduler to roll out a web service for conversations. Besides, we also use DolphinScheduler to scale ClearML for production level model deployment, but we are not getting into that in this chat. The goal of our experiment is to let Llama 2 to speak Chinese. The Llama 2 check 13 billion model is very powerful, but it's not that great to speak Chinese, even though it gets what Chinese means. The main reason is that when the model was being pre-trained, there was just not enough Chinese data, only about 0.13%. Here's an example of a conversation with the Llama 2 model in Chinese before it was fine-tuned. Even though it gets my Chinese, but it still responds to me in English. But now, after we train it up, it's doing a great job to speak Chinese. We can see the image for the result after training. Oh, okay, let's take a look at this video. This is the DolphinScheduler. We can click the project, then enter the LLM project. Inside the project, we can see the message of all tasks and workflows. After we click on workflow definition, then we can see 3 workflows here. The first workflow is data preprocessing. We can click to enter. Then we can see the tasks within data preprocessing. It contains 5 tasks. Now we can also look at the model training workflow. It contains two tasks, pull data and training. The third one is a deployment workflow. It will start three processes. Since there is a sequence to start the process, we set up some tasks to match the sequence, to manage the relationship. The above is the definitions of workflows. Next, we can look at the workflow instance. Workflow instances are generated after we run the workflows. There are two instances. Because the training time is too long, so I ran one in advance. Next, we run the data reprocessing workflow. We set up to sample 10,000 pieces of data. After confirming the workflow instance is running, we can check the status of the workflow. The data comes from two sources. The first one is ShareGPT. We can check the logs. After it processed, it will become fast chat format data, more than 20,000 species. In addition, we have Chinese alpaca data. It's also made into fast chat format data. Both have the rules of human and GPT. And after the data is processed, we will merge them into a single dataset to train the model. This is all the data. We sample 10,000 from them. Our goal is to make Llama 2 able to speak Chinese. So I use the Chinese instruction data and multi-turn dialogue data to improve its Chinese multi-turn dialogue skills. Next, let's look at the task running stage of ClearML. After the task is run, we can also get the ClearML dataset web page address. Let's open this address. Then we can see the dataset here. There are two versions because I have run it once before, and you can see it's being uploaded. Let's fast forward the video. We can see that the task is complete now. Back to the DolphinScheduler side, the task has been complete. Next, we will run the training workflow. For the versions of dataset, we can choose the newly upload v1.0.1. And then we select the model-based Llama 2 and we select the fast chat format data and the path to save the dollar weight, numbers of steps to run. We generally set a higher number, for example, 10,000. Here we set 1,000 for a quicker run. We choose two GPUs and then confirm. After confirming, we can check the instance of the model training workflow. There are two tasks here. The first one is to pull data from ClearML, and the next one is training. We can refresh the status. Now we can check the training task in the log. The training code comes from QRoller with some modifications. We can refresh it again to see the new log. Then we look at the experiment records of model training in ClearML. We can also see our configurations. All the configuration information is here. For example, we use 4 bits to run QRoller. Back to DolphinScheduler. Let's check the new log. The model is currently loading. Because the training will run for a long time, let's take a look at the model training workflow instance that has been run in advance. Then we can check the log and we find the records of the task to ClearML platform. All logs will be here. including the task ID and our configuration of the start command. The amount of parameters in model training. This is the loss. At the end, we can also see the performance. We can check more performance indicators, such as the training situations, epoch, the training time. Also, we can check the situations of the loss. ClearML contains many indicators. These records of these indicators are automated. We also can see the configurations of task executions. They are all fantastic features. So back to the DolphinScheduler, after the model is trained, we can deploy the model. Let me stop the training workflow to free up the GPU resource. We can stop the running of the workflow, and we can choose the path of the model just now and the checkpoint. Let's see what we have chosen. The last one, 1,000. We will go back to DolphinScheduler and set 1,000 step and confirm. After running, we can see the deployed workflow. It will keep running, it will not stop. Okay, we can see this is the model loading. You can see the model path information. Let's wait a moment. We will speed up the video, speed up our model deployment, running situations. Then here, Gradle has already run. We can check the Gradle log. Here we'll print a demo URL, and we can copy the URL to visit. Now we can talk to the model. I say 你好, that means hello in Chinese. Then it will now reply to me in Chinese. At the moment, it can already talk to me in Chinese. The funny part here is because many of our data contains OpenAI model introductions data, so the model also learns this information. Let's let him write a poem. Now he writes poem in Chinese. This can initially achieve our goal. That means we can make the Llama 2 chat model speak Chinese. Using ClearML and DolphinScheduler to fine-tune the model, you can also use your own dataset to train such a model. That's all the introductions of the demo. Thanks. In terms of DolphinScheduler, we simply change task into a workflow and set up the environment. That's it. When it comes to ClearML for data management, all we need are 3 lines of commands. Also, during model training, by adding a few lines of code to the training script, we can track this progress of our experiments. The first step is to initialize the ClearML task, and the second is to add a ClearML callback into the trainer. It's very powerful and easy to use. That's all I've got to share with you today. Thanks everyone for tuning in.
Thank you.
Thank you. Thank you, Jiaguang. Let's move to Q&A now.
Awesome presentation.
Thank you for the presentation. It's wonderful. So let's move into Q&A. I will edit that. Our first question comes from Sophia, and I think, Jiaguang, this one is for you. What are the next steps after using ClearML serving?
Okay. I think we can use DolphinScheduler to orchestrate ClearML serving. This way, we can deploy production-level model service, not just testing service after model training. ClearML serving is very powerful when it comes to deploying models. I once posted an article on how to use DolphinScheduler to schedule ClearML serving. You can find it by serving the keywords ClearML and DolphinScheduler.
Okay, so people can search for that. We have another question from Steve. Maybe Victor, you can handle this one. We are training LLMs and need heavy-duty data processing. Can this training be used for that?
So I can take this one. So yeah, I think DolphinScheduler is very, very good. I didn't completely understand the question because my speakers are very bad here. But I think DolphinScheduler is very, very good at the pre-processing step. So yeah, this can be used as any step in the pipeline. So if you have to do heavy pre-processing, you can just add it there. And then ClearML can always be used to keep track of everything, because that's kind of the flexibility of ClearML in comparison, like not in comparison, but in conjunction with other tools, is that you can just use it to track everything. It doesn't have to be a model training step. It doesn't have to be specifically fine-tuning a model. It can be anything. And so we use it quite often for tasks involving quality assurance, involving pre-processing or post-processing. In fact, even the deployment that was done by DolphinScheduler is actually handled as a task. As a task, and a task is an experiment in ClearML. So it can basically be used for anything, and you can also just use it to track logs or to track inputs and outputs of a Python process that isn't training a model.
Great. And one more question as we're running out of time. We need everything to be local. Is this possible? Victor, do you want to handle that?
Yeah, sure. So yeah, definitely it's possible. I think the guys at DolphinScheduler are awesome for releasing such a cool tool, completely open source. ClearML also is open source, so the package and as well as the server actually are completely open source. ClearML also has hosted offerings, but if you need everything local, if you need power over your own data and run everything on your own machinery, it's completely possible for both tools.
Wonderful. We are out of time for this session, so everyone else who has left questions, we will get back to you. So don't worry, we will address your questions individually. I want to say thank you to everyone who is attending. Also, a big thank you to Jiaguang and Victor for presenting today. I think everyone has learned a lot. So with that, I'm closing the session. Thank you very much.